and start my spiel. Thanks for joining us this afternoon, everybody. It's 3 o'clock right on the dot. For our first kind of later in the afternoon webinar, but our presenter today is a busy man, working with builders all the time and really doing some innovative and interesting things. So this was the hour he had, so this was the hour we get, and very happy to have him. He actually gave this presentation back in May of last year, but he's learned a few things since then. And it was frankly just time to rerun it anyway. I've noticed we have about 60 different jurisdictions in the state of Texas that have moved to the 2018 IECC now. So it is more and more relevant to those jurisdictions. Anyway, my name is Jason Vandiver. I'm an Energy Code Program Manager for SPEAR. And with that, I'll go ahead and turn it over to Neil. Neil, if you don't mind just introducing yourself, tell us a little bit about yourself, who you are, what you do, and then the floor is yours, sir.
Sure. My name is Neil Friedberg. I work for Owens Corning in the building science group. Depending on what the project is, my territory can range from half of the United States to all the United States and Latin America. I do projects down there too. Yeah, so I cover construction practices, both residential, commercial. It's fun. But yeah, let's just get right into it. All right, so what are buried ducts? Do they work, and how do they install them? So one of the things that we learned about buried ducts is that it used to be an approved process, and it was never in the code. And so a lot of jurisdictions were like, nope, you can't do buried ducts. It's not approved in the code. So it has to be hung, for any moisture condensation. But it's now being pushed by energy codes, right? So we're looking at becoming much more energy efficient. There are goals for the US, 2030 goal and the 2020 goal for California becoming net zero. And all these goals and all these items that we're looking at are contributing to more insulation, tighter homes, higher standards for homes in general. So when we talk about your high performance options, the whole point is to reduce thermal loss and duct leakage. So there's a couple ways to do it. In a vented attic, you can bury the ducts. Your ducts have to be well sealed and in a vented attic, or which is 100% much more a preferred option, is have it actually in the conditioned space, right? That's actually what we want. But once you gave builders that option to allow them to use that attic, allow them to put the unit in the attic, you're not going to get them to move it down unless it becomes a mandate by code. Or you can go the unvented attic and have them hung as traditional attic, but you get the insulation to cover that whole area. Now, one thing that we have learned in the field that's not in this presentation is called stratification of moisture. And what happens is, even though that ridge is really, really hot, in some areas, it can actually be really, really humid. So upwards of, 80% relative humidity. And this is why when you go and see homes that are 20 years old plus and you see mold coming off, it all starts at the roof deck. It all starts at the roof ridge, the roof ridge, where you see these issues in the field. And some of you are probably nodding, yes, I've seen it. It's because up in that area, regardless of temperature, it just stays humid. And as you get down, as you come down from the ridge, it gets cooler, but the humidity actually decreases. That's one thing that we found while censoring, I think I'm on my 16th, 17th home where we do full censoring, right? So let's actually focus on buried ducts, right? So what we're going to talk about, the concept language, do they work, field data, cost and some energy analysis. I'm not really going to focus on the cost just because most of you guys actually probably don't care about the cost much more. You guys actually much more care about the concept, code language, field data, and then how do you install them? That matters because inspecting them is important. All right, so buried ducts, what are they, right? So it is what it is. It's a duct and it's buried by insulation. This one just happens to be an image that was taken from HIRL, Home Innovation Research Labs. And what they did was they have a combination of square and then flex duct on the registers. So one thing that we want to do as a goal of this is to get it as low as fast as possible. So if you look at this picture, it shows the main trunk line going over the joists, and then the actual trunk line, the trunk line that goes to the register on the ceiling floor. The lower, the better. One of the other things that we talk about is what is the R value of the duct. Now, I will add a caveat to this. So one of the things is that we have to separate it by climate zone. Why? Because climates aren't the same everywhere, right? If you look at the map, R8 is a ginormous portion of the United States, and the R13 duct area happens to be about 50 to 70% of all construction in the United States. So you can see the huge difference. In climate zone 1A, 2A, and 3A, we are required to put an R13 duct. Now, this is my caveat. In the field, we've found out, and in a couple of things that I've done, we found out that R13, one, doesn't exist, so you have to actually fabricate it yourself. But two, it's actually, it's a lot more work than necessary, because we believe an R8 duct will work, and that's what I'm going to be doing with NREL and Building Science Corp in the Galveston area, is testing if we can do an R8 duct in an attic. But the effective R value of it in R 403.3.6, one of the things that we get to do is actually set standards to what needs to happen. So you have the duct in a very specific location. It's surrounded by insulation greater than R30, and it has to be topped with a minimum of a 3.5 inch of insulation below. And so deeply buried ducts end up taking the effective R value of a R25, if that makes any sense to anybody. So basically, you have an R25 around the duct, and then the duct itself.
And that's so if I'm submitting my rim rate, if I'm doing an input for my performance report for permit, you're saying that I can list R25 as my flex duct insulated value?
Yes, correct. Yeah. Yep. Because effectively that's what you have, right? You have such a deeply buried duct that the insulation around it is keeping it almost in conditioned space. And we have data to show what we're talking about. Thank you for the question. So the condition space criteria, right? So for energy modeling, right? Because technically these ducts are not in conditioned space at all. So the buried duct allows us to say, hey, the unit should be in conditioned space. There is code language that allows the unit not to be in the like a closet. It could be in the attic. But 1.5 CFM per 1,000 square foot of leakage to the outside. That is important, because that basically is equivalent to that makes the effective leakage so minimal that it's acting as if it is in conditioned space. And then the benefit of the R value is that you get to use the R, you get to reduce the R value over it as long as you deeply bury it, right? So that, if let's say for the picture under 3, it's a R38. Well, it's not an R38 directly over it. The top to the ceiling would be continuous in R38. So the insulation underneath, insulation on top account to the R38. And then of course that, I spoke about the air handler being in the envelope. While, on paper, that's great. I know in practice, it's almost impossible. I've worked on, I worked with a builder trying to build, what we ended up calling a doghouse in the attic, just to encapsulate the unit, and it's just a difficult process. So if it's not designed to be in the attic, I mean, if the unit's not designed to be actually in the conditioned space, there is a way to do it in the attic now. But I don't know if the code language has been approved yet. So I'll probably have to get back to you on that.
For the air handler?
Yes.
Now, my understanding of, well, now granted, my understanding is that, now are you asking, so my understanding and the way I read it is if the air handler is in the attic, you can still, that's when you can say that then you can use R25 for your duct. But if your air handler is in conditioned space and you're less than that, the 1.5 CFM, then you can say the ducts and the air handler in conditioned space. I thought you couldn't say that the whole thing was in conditioned space. I
think you're right, and that's a caveat I'm not familiar with.
Okay.
Because I've been implementing it. I haven't been, sitting at a desk talking about it anymore. You know what I mean?
Right, yes. Right. Yeah, so you're making it work in the field. You're not worrying about code.
Yeah.
Gotcha.
So you're probably absolutely right. And
okay.
And I apologize for not being 100% up to date on that situation. But
no worries.
Right. I think this is considered conditioned space, but otherwise you get to use the effective R value of 25 for the other condition.
Yeah, I think that's
right.
But
it is allowed, right? There's two options is what I'm trying to say.
Okay, sounds good.
Right, so buried ducts is what the bare minimum allows you. So can you guys see my mouse? I don't know.
Yes, we can.
Okay,
we can see it moving.
Perfect. So the nice thing about the buried ducts, right? So here, let's say you have an R38 and here you don't. That's typically not considered acceptable. What we end up having to do is having to mound it over, and you'll see pictures later where we mound over the little trunk lines to maintain a somewhat continuous, R value. But then there's the deeply buried where you have it so low that this is where you get that effective R value, right? So it acts as if, and mind you, it doesn't have to be this where there's like a chase. It could be like this, but the insulation level above it has to be much higher. Does that make sense?
Absolutely.
Okay, and then
that's how I read it as well. You have to have the full 6 inches on top, so it has to be mounted.
Yep, correct. And then so this is what we're doing with deeply buried ducts because of costs. Is where we're building while it's not approved yet, and I think we went. I think we were working with Joe Stebrick on this. What we're talking about is basically building a dam on both the right and left side of it, and making the duct itself be in a deeply buried situation, while the other portions of the house that don't have ducts, don't have any issues, can be, the R38, R49, depending on what you want to do. Sorry, my phone is going ham for whatever reason.
You're a busy man. Okay.
So this is the fun part, right? Is buried ducts effective R value table. This is what we end up going to, right? So if you have a 4-inch and you have an R13 attic insulation, it basically tells you what needs to be blown over the duct, right? So if you need an R30, you have a 4-inch, then you need an R13 over that to make it an R30. The reason why is because we're allowed to calculate an R. So let's say this was climate zone. This was a climate zone that needed.
And this is in California, though. I noticed this is coming from the ACM reference manual in California. This wouldn't be exactly how you would do it in Texas, but it does work that way in California.
I feel the jab. Skip. Got it.
No worries. But no, that's good. That's good information though, because that gives the math. Okay, this is. I mean, just because A lot of times as a code, I know me as a code inspector, you know, back in the, before I got clean and quit writing red tags and fell off the wagon and all that good stuff. A lot of times you see things in the field, and just being able to have that background math or that background knowledge of how that might work. I mean, I think that's beneficial. So I don't, California is some crazy in some areas, but they do some good things in others. So
Yeah,
okay.
but I mean, the nice thing of this table is, while yes, they use in California, it's still a good reference manual everywhere else. Because I use this table to justify, you know, how much R value goes. Because you always get that question. Well, I have a 20-inch duct. What's my R value? And it's not on the table. But if I have a 12-inch duct, I need this R value. How much do I need to go over, right? So it's always a really good reference.
Yeah, absolutely.
Yeah. So and then California criteria. Sorry, this is our generic overall installation, right? So the one thing about this is when they first came out with this, and the reason why climate zone 1A, 2A, and 3A are what they are with an R13 was because they took an R6 duct and they sprayed it with about an inch of closed cell on there, and that was roughly an R13, and so that's where that number came from. There's not a manufacturer to date that has an R13 duct. So what we do in the field is we have to pull an R8 duct through an R6 duct. I have a chart for that. It's not on here. But once again, we've done studies to show that that's a little bit overkill. All right, so in-field data. Now this is where it matters. So a majority of the stuff that came from Hurl was done in a Ladysmith Island test home. And this was one that we worked with, I forget the builder, I apologize, that someone else instrumented, and we just basically observed, right? So they required an R8, they had 49 loose fill, we measured temp and humidity, almost a year's worth of data. And so you can see here that while around the duct itself, RH is changes rapidly, especially in an area that climate changes rapidly, because attics are constantly changing. They're not constantly at 120. You know, they warm up throughout the day and they cool throughout the night, and so because of that, it affects the R value, the relative humidity in that space. So the one thing that we're doing is currently these blue stars are the test homes that I have currently censored and collecting data on for buried ducts itself. The red ones are proposed locations. The one in Galveston is going to be 5 homes. We're looking at doing one in the Panhandle, doing one in South Florida, and doing one out there by Daytona Beach. All this to understand different roofing and how it affects the buried duct situation. Because one thing that we did learn in modeling is that a radiant barrier actually can increases the chance for condensation on ducts. So we actually want a hotter attic than what we would typically want. And I know people are looking at this and going, that's insane, because it's totally opposite of everything that we've done in Texas. Because you can't almost find a builder that doesn't have radiant barrier.
Well,
but the fact that the temperature, well, I mean, the fact
warm
that
air
the
holds
temperature,
more water, though, right? I remember I was giving a class in Beaumont, and their solution for their ducts sweating and dripping was to plug up all of their ventilation. So like, oh yeah, man, now my attic gets up to like 180, but it'll hold all that moisture. I don't get condensation anymore. And I'm thinking to myself, there's a better option. But anyway, go ahead. Sorry.
yeah, but you're right. I mean, that's basically the situation. Is we're increasing the temperature, reducing relative humidity, and but we know that is not a good option for everywhere, right? Especially when builders have competitors that use radiant barrier, upsell radiant barrier, and say your attic is gonna be cooler to store more things. And we as I work with builders, I realize how much they actually hate the fact that people put storage stuff in attics. But yes, so they utilize that for storage, and this is one of the items that we can't have currently in our modeling, but we want life, you know, we want real life proof where we test different attics. We're gonna do tile roofs. We're gonna do, you know, asphalt roofs, and in a year or two, but we'll probably be testing, you know, reflective light roofing. So just to see how it works, even though I don't know a single builder who actually utilizes that system.
Right. It's crazy that, I mean, black architectural shingles and our equipment that makes cold air in our 150-degree attic. That's a great idea for Texas. Real quick, Neil, sorry to interrupt. I forgot on the housekeeping side. We have 108 people on the webinar, so I can't unmute folks for questions, but there is a chat bar and a Q&A bar. If you will just type in your questions on the chat or the Q&A, I'll answer them the best I can while Neil's giving his presentation. Those that I can't answer, we'll save for Neil at the end. Sorry about that. Go ahead.
Yeah, no problem. All right, so climate zone 4B doesn't matter to us. This was the Ladysmith stuff. This is the one that we monitored and we're testing, and we found no condensation to date. We actually have pulled our sensors from that, but there hasn't been much of a concern. Yeah, okay, and then climate zone 2A, and this house happens to be in, you know, some of you Texas people will you know, enjoy it, but so in Clifton, Texas, basically west of Waco. We monitored a house. We did buried ducts there. It was an R13, and we found, I think, because we're actually still monitoring that to this day, but this is typically the season where we see the transition. We're from hot to cold, from, you know, cold to hot, back to. So we want to, you know, during this process, we have not seen any major dripping, any major issues in that. And this is, once again, this is a house without radiant barrier. It's an R13 supply trunk. And, you know, one of the benefits of actually doing buried ducts is the cooling capacity is actually decreased. And let me explain myself. When people design ducts in Texas, they have to design ducts that go from, like Jason said, the hottest part of the house, right? So we have to, they have to oversize HVAC units to cool the added heat that comes in through that duct. So as you're pushing air through there, all that heat is coming in through the duct, and you have to increase your tonnage to increase cooling capacity. But with buried ducts, we would actually require, so this builder wanted to put a 4.5-ton unit in a home, and we fought back and forth, and we settled on the 3-ton unit, even though I believe a 2.5-ton unit would have done a better job because of short cycling, right? And the reason why I say that is because, I'll show you in a different slide, the difference from supply to a 39-foot run where it goes to the duct was 1.4 degree difference. So you're basically getting, you know, 55-degree temperature on the coil, you're getting 56 into a room. And what happens is you hypercool that room, causing short cycle. So here's a combination of some of the areas that we were looking at. This happens to be another builder in just outside Georgetown. Sorry, not Georgetown, Round Rock. So it's just outside Round Rock. So by Austin area. Checking, you know, temperature, relative humidity. As you can see, we have relative humidity in very particular areas, right? So the top is very high, but as you get lower, you can see that the relative humidity decreases in the insulation itself because the temperature also changes. And then on the right-hand side, where we have you know, where it is going to become inevitable, where you have some sort of duct on top of a duct situation. We wanted to see how compression works and how all those items work. And you can see that while there are times where it gets high up there, which happens to be at the top, the lower one that is actually carrying, so this is a return over supply. So the return air is warmer and the cooler air is the bottom. You can see that the blue is actually what's being pushed through on that's a duct that's carrying all that cool air, and that relative humidity is staying relatively in the 50s to 70s. So never allowing it to actually condense. All right, so this is where I was talking about. So this is the longest duct run. This was where I effectively said, look, here's the attic temperature, right? So here we have days of 140, come down to 75 in the evenings, come back up, and you can see where the system is on and off, right? These little peaks are on and off cycles. Where it goes on, they decrease, it turns off, it increases. Someone leaves the house, it shoots up high. The system, I'm reading temperatures. And as you can see here, the blue line is the supply air, and that orange, the darker brown is a much more constant, is the longest duct run. So you can see that on average, they're almost not different. So on hot days, you can see that you're gaining anywhere in this area about almost 2 degrees total here. And on days like this, where it happens to be cooler, you're seeing almost no difference. So you're getting, that 60 degree air coming into that room.
And that's R13 supply, no radiant barrier.
Yeah, I apologize. It should be 39 foot. Yeah,
Deeply
this is a
buried.
non-radiant barrier attic. Yeah.
Okay. Cool.
And mind you, it takes a long time to find where the unit is running constantly, because remember how I said that I argued with the installer saying, hey, look, we need a 2.5 ton. He's like, no, I'm gonna put a 3 ton. I don't trust you. Well, this is what you get. You get short cycling. So finding a time where the system is running and it's running at a continuous cycle to where you can measure both supply and return, that's what we're looking at. And then this is just a much more zoomed in view over here, right? So where you can see the very minimal degree difference. Because you can see once it's constantly on, it's almost exactly the same here, and it rises up at the same rate, right? So once the system turns off, it actually increases at the same rate, because the whole thing is under the same amount of insulation.
Yeah.
So these are some of the stuff that was done by the Home Innovation Research Laboratory. Was the buried duct stuff, where they talked about the dew point gradients, the buried ducts versus not buried, right? So technically the duct that you're looking at would be considered a not buried duct because there's no insulation above the main cord. This is just talking about the Lady Smith Island experiment. This is the cost. I'll talk about it real quick. So one of the things that we found out was, what cost to the builder is the concern for this. And what we realized that there's not much to it. Even in our field testing that we're doing now with the homeowners, the home builders that are being, showing us their data, we're noticing that there's not much of an increase to what they're doing, because hanging a duct and laying a duct it costs them no extra money. The only added cost is just the amount that whatever fiberglass insulation or cellulose insulation you choose to put on top of it would amount to. And what we're seeing is, depending on the joist size, right? Because if we're doing rafters, 14-inch rafter, I have to insulate 14 inches underneath the duct and then the duct above it. So that adds some cost. But if you're doing like a truss-built home where it's a 2x4 bottom cord, it becomes about a 1.2 times expense on insulation versus like an unvented closed cell foam, which would be never used in Texas on the roof deck.
Now, are you looking at a 2x4 truss like that? Would your recommendation be to have 3.5 inches of insulation and then run it across the top? I mean, obviously I saw in the other picture, ideally you're running it parallel to the joists and you can run it right on the drywall, but where you have to run perpendicular to the bottom cord of the truss, you want that duct running laser straight. So you want 3.5 inches of fiberglass underneath it. Is that right?
Yeah, correct. Okay. Correct. That's right. And we've done enough jobs to know that you have to roll with the punches. You can do so much on paper until you get to the field and see how they actually built it. then you kind of have to, adjust accordingly. The one thing I do always recommend is if a builder does decide to do buried ducts, is put ducts in first, because they don't have to jump over pipes. They don't have to jump over a bunch of electrical cords, cables, conduit. It's all out the way. The ducts are where they need to be. That's what we're focusing on, because that's what's causing the energy efficiency. That's what's causing the comfort, right? So all these callbacks that they deal with, if they focused on just one thing, and it would just be the buried duct situation, and then added things later, it's much easier. Now, one of the things that I always recommend is test after mechanical and plumbing electrical and plumbing are done. Before you end up putting gypsum, because if you have to fix a pipe because someone trampled it, stepped over it, I always recommend doing a duct blaster test then. But most home builders like to do it at the very end before the homeowner moves in. All right, so as far as ERI, based on the 15.4, because you get the ducts in conditioned space and because you get the R value, you can see that there's a huge decrease versus a standard home duct layout versus a buried duct, and then on top of that versus that truly ducts in conditioned space, right? So there is a gradient, and I understand that now we're on version 16 something, and some people just use that the state standard code here. So installation, right? So Owens Corning ourselves have set up a set of guidelines based on our experience. At the moment, I don't know of any other manufacturer that has done this. So if you end up looking for buried ducts, you're gonna find us, but we are trying to work with other insulation manufacturers because we feel that it's a wonderful solution to home efficiency for the future. So we have to look at the ceiling R value, the standard duct design, and the R25 credit for condition criteria, right? So we have to talk to the framer in case there's anything that needs to be done. And then the HVAC has to be installed and sealed, and then insulator has to properly cover it, right? And for HVAC, once again, we're just bringing it down. And so I'll be honest with you, all the HVAC contractors that I've worked with have liked this system because it does actually two things for them. One, it's less labor than to hang it because they don't have to go up there in the attic and start strapping things up. And then two, they typically have to sell a much more efficient unit because of it, because they have to go down in the tonnage. So in my experience, most HVAC contractors end up selling a 2-stage and sometimes even an inverter. And I will always recommend an inverter system for this because of the way it works. Right, so we have to consider a couple things with ducts. This is one of the items that is crucial, right? So how we lay our ducts and calling them compact. Let me just load it all up. So once again, putting something on paper is not the same as doing something in real life, right? You have the situations where you have those taller joists or any sort of like glue lamp beam that it has to go over. But the other part is that we want to get it as under and as close to the gypsum as fast as possible. And if not, then we just have to find a solution to where we can bring insulation over it. The other thing that we want to do is we also want to shorten things, and you'll see that here, right? So we want a compact design where we use our ventilation duct boots to throw air rather than coming all the way to the edge. And the reason why we do this is because in Texas, one of the wonderful things that we do is we do vaulted ceilings at almost all edges. It feels like it's almost standard. And so you will not be able to get enough insulation over a duct if it's at the edge. If you were doing an energy truss, the duct at the end doesn't matter because it can be continuously buried all the way to the end, right? So that's one of the things that we do have to consider is we have to pull all these ducts in to make sure that we're going to be able to get a proper coverage on the ducts. Plenums, and so we use side mount plenum trunks and boot connections. to help maintain. So what we don't like is we don't like a top mounted, because what happens is that duct has to climb up and then come down, and that affects the airflow, air pressure, especially in a static control system. Right, so 90-degree boots is one of the most beneficial. The other thing that we did note in our studies, that in Texas, if you're gonna do anything, you don't want interior insulated boots. You want exterior insulated boots. And the reason why I say that is because fiberglass is air permeable. Air at high rate pushes through that unless there's some sort of coating or some sort of a barrier, and causes the outside of that metal to be cold, and metal is a condensation point. So one of the things we also look at is covering up all the connections. So everything has to be covered on the external side. It may have an internal R value, but the outside matters more. So here's a run. Here's a run where we have a flex duct trunk. We have a T going off of it on a vaulted ceiling. And as you can see, we'll have plenty of room to have the whole R value go over the trunk itself. Short run to a boot over a big engineered member there, and you can see that it's externally insulated. All right, here's another view in the same home. This is the one in Clifton. 100% covered on the exterior, while as you can see inside, it has insulation, but it's not enough for buried ducts. In fact, that's actually our Achilles heel, is the boots, because the metal has a much better chance of causing condensation. Corpus Christi, hint, hint. So our values based on the region, we talked about it. Here we're talking about an R13 duct because it's what they tested. Like I said, we're testing an R8 duct solution, and we, based on our modeling and some of the field data that we have, we actually know that an R8 duct will perform equally as well. So you probably guys, it won't be until the next code cycle. It probably won't be out to 2024 when we actually go debate it. But that is one thing that we have realized and that we're going to be working on with HURL, with NREL, and with local municipalities if possible. But otherwise, builders currently have to create an R8 within an inside an R6 or vice versa to get that R14 to consider an R13 duct in our climate zones right now.
Were you at the code hearings? How did R13 even make it into the code when it doesn't? I mean, I figured that's one sneaky manufacturer, that the only one that makes an R13 flex.
No one makes an R13. It was what was tested. Like I said, they tested an R6 with an inch of closed cell spray foam on it, and it worked well. And that's how we got that number R13.
Gotcha.
That's it. There, not a single manufacturer makes an R13 to this day.
That's unfortunate.
Not even us. Like, we don't make it. There's not. We'd have to have a reason to make it. Yes, code is enough, but if there's not if the marketplace isn't going, hey, we need an R13, please make one. People don't make it. So we have to manually make it currently. So this is an example of what it would look like, and the reason why we can't, why we want a compact system, right? So you can imagine if that duct was further out, it's against the hot roof deck, and it's literally equating our R value to 0, right? So it's far back enough to where you're going to get that nice mound. There's a ruler system you can see there in that pink flag. It's basically construction tape, and then they tape it or on the bottom, slap it on top, and then staple a ruler on it, so that way you can actually see how much R value is going to be over that duct, and you can obviously see where that is. We talked about this already, right? Decreasing boot connections should be sealed, as always. And that's one thing I always tell builders is when you give the painters the option to cock the register, what they do is they cock it to the ceiling, but what they were paying for was cocking this little joint here. That hole is crucial to making sure that we keep air, our airtight layer. right? So one of the things that we want to do is keep ducts flat in the attic, use side mount taps everywhere, minimize duct size, duct lengths, and reduce the option of crossing over, and seal all connections and insulate the boots properly. So insulating, sorry, I'm looking at my watch, making sure. So once again, here's another picture of a depth, a ruler or an attic ruler with a simple system. There's no patent on it. It's simple, it's easy. People can read it and see it. And as you can see, this trunk is crossing a bunch of truss cords. But as soon as that intersection comes where that register is going to come off of it, it's going down immediately onto the gypsum. So that's crucial when talking about it. And of course, baffles to prevent airflow from moving them. On attic roof systems, we ask dams. So in this situation, on this plenum, what we would do is build a dam, because the plenum also has to be buried under insulation. So they would have to have a creative way of stopping that insulation from just toppling over, but allow enough area to where someone can work in that area. And then so you can see here where the buried duct is, right? It's right there against that in that truss cord with that mount, right? So burying ducts at the depth, right? So this is like, I don't know what R value it is, but let's just all say it's an R38, right? So if this is an R38, that means that has to be whatever the difference of that duct is minus that R value of the duct over here. And then, so on this, we want to make sure we have depth gauges. As you can see in this previous picture, we don't have any depth gauges, but you can tell where the trunk is. Extra baffles that are needed, no radiant barrier. Currently, that's kind of what we're sticking to. We will be testing radiant barriers this year, hopefully, if not next year, and seeing how much they actually affect possible condensation on ducts, both R13 and R8 ducts, and insulation dams around the units. And once again, the most vital, it's last, but it's not least, it's right sizing the unit. If you oversize the tonnage, you're going to cause short cycling, causing comfort issues, causing mold, causing a lot of issues in a home. And that's one thing that we have to avoid. So in conclusion, we get to reduce the ERI score, improving with code compliance, installing an unvented attic or ducts in the conditions, with getting ducts in conditioned space, using energy efficient measures for trade-offs. And then the other thing is, we want to make it, build it tight, build it right, both the duct and the home, right, and keeping costs down. But that's it for me.
I can't believe you mean you have HVAC contractors that would willingly oversize a unit? That doesn't happen in reality.
Sarcasm.
It's unbelievable, man. I had, no joke, Neil, probably 600 HVAC contractors in classes. All across the state, I did them, and 19 out of 20. And I preface the question with, "Hey, I'm not turning y'all in or anything. I'm just curious. Who does residential construction?" They raise their hand. Okay, of you, who does the manual J load calculations on their jobs? And it, without exaggerating, 85 to 90% do not do JS&D correctly. They do rules of thumb.
Yep, and that's the only concern. So all the home builders that we have, there's people who do it on their own, but all the people that we are involved with, inspectors, HVAC people, and insulators are the people at the table. When we come in there, those are the people that I care about the table. I want the inspector to be able to inspect it properly and understand what he's looking at. I want that HVAC guy to give me that, right? It's not an option anymore. It's not rule of thumbs. We need to do a manual JDS to make sure that we're going to comply properly, and you're going to properly size it based on bearing ducts. And then on top of that, air leakage. A lot of them, even if they do a manual JDS, most people end up sticking to that standard, 5 to 7 ACH 50 that's set in the program, rather than actually changing it to what it would be, right? Can you imagine how many homes are being oversized in climate zone 3 that are required 3 ACH 50 versus, San Antonio is required 5? It's hard. It's hard. It's one of the things that you work with them, and you hope to catch a lucky one sometimes.
Well, and we can certainly understand both sides, because from the HVAC contractor's point of view, you can still say comfortable. Now, granted, you probably have to keep the thermostat 4 degrees lower than you should because the relative humidity in the house is higher. I kind of understand, because 20 years ago when windows were so crummy and we didn't blower door test, well, then that rule of thumb and then erring on the side of oversizing was right. But I think it plays exactly into what you just said, is now we know how tight the houses are. Now, in addition to knowing exactly how tight the houses are and exactly how much the ducts are leaking, we've got way, way better windows. That's probably the biggest thing is, the fenestration qualities made leaps and bounds in the last 20 years. But it's a battle I'm constantly fighting. Do have a couple of questions. Let's see. I'm not sure what that one is, so I'm going to move on to the next one. It says effective R value. Oh, yeah, that's right. I answered this one. I think that's correct. So effective R values are the cumulative values for all materials within the assembly. For a R38 code assembly, in climate zone 1 through 3 only, we would need the R8 plus R6 plus R24 blown over the top per building science and NREL. Are they wrong?
No, that's correct. So
Okay.
it would be the R8 and the R6, and then on top of that, yes, that's correct. That's how we're installing it. That's why I don't know if I may have glanced over it. I said typically it would be an R38, but you get to reduce because of the duct, because you actually get to include the duct into that R38 calculation.
And this is more of a statement, but I want to give you a chance to go ahead and take Armando off your Christmas card list and respond to it. Armando says there's a huge difference when we use blown cellulose to blown fiberglass. We found the density and permeability of blown fiberglass allows for convection loops. Would you like to respond to that?
I'd like to see a study. Convection looping happens at any gap greater than 3/8 of an inch. Mm-hmm. So if you have that gap in fiberglass, then yeah, you have convection looping. If you have that gap in cellulose, correct, you shouldn't. But if you have that same gap in cellulose, you would have convection looping. If you had that gap in spray foam, you would have convection looping. Right. So it's not so much about what the material is; it's much more about the actual way it's installed. If it's not installed properly, yes, there could be convection looping. If it's installed properly, all materials should not have convection looping, spray foam included.
Right. Well, and I've seen, I've rented, I've gone and bought blown insulation just to add to an attic of my houses before. And the big box, the Home Depot of the world, back in the day, this was the case. I don't know if it's still the case, but they would give you the machine to blow it with if you bought your blown from them. And I had to take a machine back one time just because it was blowing clumpy. It wasn't doing a good job of creating a nice blown, no 3/8 gaps, real, good, consistent density. I think I've dealt with the same machine before. And what I've had to do is basically bring the hose back down and blow it all back into the actual bucket, into the where you put the insulation. And after the second time, it actually worked better. But yes, if the baffles are messed up, baffles or paddles are messed up, if there's a seal that's broken in a blowing machine, it's not gonna be installed properly. Yeah. Well, that was great. I hope, keep up the good work, Neil, because we've got to do something to, like I think what you said was very true, is once you allow the builders to start doing it, they're going to fight tooth and nail to get it back. And with real estate being what it is, especially, I mean, you go to the Austins and the parts of Dallas and Houston, it's prime real estate, and you're just simply not going to lose X amount of square footage for your air handler in the inside, and then you're not going to fur down the hallways and do the things that you could do to truly get them in conditioned space. But this is a meet me in the middle kind of approach that I think should really work pretty well.
Yeah, and we found that for the builders who want to do better but aren't comfortable jumping right to spray foam, this is a typically intermediate step for them, and you know, it cost wise, it's not much more different than what they're doing already, but they get the benefit of, if they pull a unit in, they get that ducts and conditioned space credit, which allows them to compete with people who are doing like spray foam and stuff like that. Yeah, there's benefits of it.
Well, yeah, that's the foam people. I mean, being able that R13, it seems like that's just kind of making you shoot a little foam around your I wish they would have not tested that assembly quite like that. Chris asked, he's like, well, that seems kind of like it's pushing to make spray foam mandatory almost, but it's.
No, it's definitely not. It's just, it's giving you guys more option, right?
Right.
One thing for the people who weren't here earlier, we were talking about diffusion ports. Mm-hmm. And so we have houses currently that we're testing with diffusion ports in Texas. And the reason why a majority of my stuff is in Texas is because, one, I'm here, and two, we have an extreme climate. You know, Texas has technically, I think, 5 climate zones.
4.
Right?
Wait, 2, 3, and 4. 3 climate zones, but
we also have A and B.
Yeah, 5.
5. We have 5 climate zones.
Yeah.
And you know, California is the only other location that has that amount of climate zones. You know, they have 16, but that's state local. But yeah, you know, we want to make sure it works, because if it works in Texas, it could pretty much work anywhere.
Well, and we're building way more homes than anybody else too, so you have a whole lot more option down here.
Yep, that's true too.
That was all the questions. Man, folks, we are, you've got an extra 7 minutes. I recommend actually everybody go ahead and take the rest of the day off. Tell your boss I said it was okay. Happy hour starts in 7 minutes. I'll give you plenty of time to get there. Everybody stay safe. Thanks so much, Neil. Any parting words or anything else you want to tell them before we go?
Yeah. If you're willing to be a guinea pig and work with us, reach out to me. That's not even a joke. We'd love to work with builders who are curious and that are willing to work with us. So my email address is at the very beginning, and my phone number. Let me see if it.
I sent Cody an email telling him I wanted to test that R10 foamular in my attic knee walls and never heard back. But he knows what I was getting. I think we're okay. I know Chris will reach out to you. I'm sure he's down in the valley. He's working with a bunch of different builders down there. There's his email address, Chris. I'll shoot it to you too if you can't get to it or whatever.
If you're a builder or know somebody who's a builder that wants to do buried ducts or wants to do some sort of diffusion port situation, we're always looking to test homes and work and learn more.
Awesome. Well, and if you're needing one in the Fort Worth area, I have friends that are builders in Granbury that would be happy to work with you. So if you need someone there,
I'll probably reach out to you too. Yeah,
sounds good.
You know, that's the thing is right now we have very few builders, so our list of requirements and understanding and installation, you know, instructions are very vague because we don't have enough homes under our belt to say, hey, look, here's the situation for you because we've come across this before, and here's how we would do it. You know what I mean? There's no write-up on that because it is what it is.
Right. And no, I did have a question. Yes, this webinar tomorrow will be up on our YouTube channel. And as well, everyone will get a PDF copy of the presentation. So you'll have Neil's contact information there for the builders that are on. For you code officials, if you want to watch it again or show it to a builder, just check our Spears YouTube channel. Liz normally gets it on in about a day. For those of you needing ICC CEUs, you will get a course evaluation questionnaire. Simply fill out the course evaluation and we will get you an hour's ICC CEUs. Thanks again, Neil. Great presentation. Well done as always. If you ever get down to San Antonio, give me a shout and I'll let you buy me a beer.
All right, we'll do.
Sounds good. Thanks, everybody.